What you're doing today is balancing equations, okay? But instead of doing it on the notes, I want you to do it on the whiteboard today, all right? And let me show you why. Okay, because you're going to be able to erase, and you're going to have to go back and forth, because your main objective is to make sure you have equal amounts of every single element on both sides of your equation. Okay, everyone should be unplugged. Not one person should be on a phone. No earbuds, no anything. Okay, now, this is called the tally method, and most of my students get it through this method. Now, there's different ways to balance your equation, but the first thing you need to do is figure out what elements you have. So now first, do I have a polyatomic ion here? Yes, right? The NH3 is a polyatomic ion, right? But is that NH3 on both sides? No. So you're going to separate those elements. So you're going to have nitrogen and hydrogen. Okay, we see this? Now, you need to first figure out how many you have on the reactant side, and then how many you have on the product side. So remember, your left side is always the reactants. The right side is always your products. Mija, for right now, we shouldn't be in a group. We need to be at our desk. Okay? All right, so, and you know what? We're going to have to do a new sitting arrangement and just make sure everybody's in a spot. All right, nitrogen on the left side, you have 2 of them, right? How many nitrogen do you have on the product side? Ladies, we need to be at a desk. You need to be at your desk, Mija. Both of y'all should be at your desk. How many nitrogens do you have on the left-hand side, the reactant side? Let's go, girls. So you should be at your own desk. Noelia, this means you too, Mija. Okay, how many nitrogens do you have on the reactant side? 2. Okay. How many do you have on the product side? You have nitrogens. 1. Okay. Now, how many hydrogens do you have on the reactant side? How many hydrogens do you have on the reactant side? You have 2. Okay. How many hydrogens do you have on the product side? You have 3. Now remember that your main objective is to have the same amount on each side. The only place you can place a number is in front of an element or a compound. You can never ever put it in between, okay? All right, so if we want to make the right side equal to the left, here for nitrogen, we can put a 2 coefficient. Not only does that give me 2 nitrogen, so it changes this 1 to 2, but it also gives me 2 times 3. How many hydrogen would that be? 6. Very good. Okay? So kind of think of it as your FOIL method in algebra. When you have a 2 in front, it multiplies everything inside the parentheses, right? So it's kind of like if you had parentheses and the 2's in there. It multiplies to everything inside. Okay? All right, so now, on the other side, what's unequal? The hydrogen. Very good. So if I have a 2, 2 times what would give me that 6? Yep, so I can put a coefficient of 3, and this gives me a 6. Okay? Now, did we have to do anything to this one? No. So anytime you don't need to do something, that coefficient is going to be a 1. So my actual coefficients are 1, 3, and 2. Now, once you get your coefficients, you need to look at all of them. Can I reduce them? Can I reduce all of them by the same number? No. So this is my correct coefficients. Okay, now someone last period asked me, ma'am, what do you mean by reducing them? Okay, so let's do a little example. If your coefficients had been something like 4, 6, 10, let's say 4, what can I reduce all of them by? By a 2. Okay, so it's like dividing by 2, right? So 4 divided by 2 would give me what? 2. 6 divided by 2 would give me what? I heard back there. 3, very good. 10 divided by 2 would be 5. And 4 divided by 2 would be a 2. So your most reduced is your correct coefficients. If you can reduce, you have to reduce. Okay, if you put this instead of this one, it will be incorrect. All right, you must reduce it if you can. All right, are we okay so far? Where do we have a question so far?
How do you get the 2 in front of the NH2?
We decided to put a 2 in there.
So you just,
Right, it's kind of like a trial and error. You have to see what coefficients are gonna make it equal. Remember that your whole objective here is to make sure that the equation is balanced. So whatever you have on the reactant side, you must have it on the product side. Okay?
why did you put a 36?
A 36.
Right to the right of the H. You covered. Oh, okay.
Okay, I don't see a 36. Where are you saying a 36? Okay, you got it? Yes? Okay, let's do another one just to make sure that we're okay. All right? Okay, so let's do something with a polyatomic ion. Let's say silver nitrate. And let's do magnesium chloride. Now, let's do silver chloride. And let's do magnesium nitrate. Okay, now for now I'm giving you the actual chemical reactions, okay, or the chemical compounds. You could get words, and remember anytime you have something in words, you have to do the crisscross method, and you have to switch those charges and get the correct chemical formula before you can actually do the whole equation, okay? Now look at this equation. Do we have a polyatomic ion in there? Do you have a polyatomic ion? Yes. Do I have it on both sides? Yes. You see how you have the NO3 on the product side, and then you have the NO3 on the reactant side? As long as you have it on both sides, you can put it together. Guys, this is a little shortcut, and it's going to make your life a lot easier, because sometimes you can have an equation with 2, 3, sometimes 4 polyatomic ions. And all those oxygens, you don't have to separate them if you keep them together. As long as the same polyatomic ion is on both sides, you can use it as one unit, okay? All right, now what other chemicals do we have in there? Yep, Ag, very good. What else? Mg and Cl, very good. Okay, so look at NO3. Look at the whole thing. How many NO3s do I have on the reactant side? NO3 is all together, it's one unit. How many NO3s do I have?
1.
You have 1, okay? Now look on the product side. How many NO3s do you have? 2. You see how that number is outside of the parentheses? Because remember that 3 is included with the NO3, so you don't have 3, you have 1 NO3. Mijo, can you answer that for me, please? Okay, so now how many silver do you have on each side? You have 1 and 1. Okay, hold on. How many magnesiums do you have on the left-hand side? You have 1. How many magnesiums do you have on the right-hand side? 1. Okay, how many chlorines do you have on the left-hand side? 2. And how many chlorines do you have on the product side? 1. Okay, now, remember the last equation? I told you can just start with whatever element you wanted, okay? Because you didn't have a polyatomic ion, right? But here you have a polyatomic ion. So whenever you have a polyatomic ion, I would begin with those first, okay? And that will make your life a little simpler. So that is unequal. What can we put on the reactant side to make it equal?
2.
2, very good. Because this 2 will give you 2 NO3s, right? And so that changes that to a 2. But what else does it change? The Ag, right? Okay. So now, because that changed the Ag, it's going to change the other side, right? Okay, so what can we do to this side, on the product side? We can put a coefficient of a 2, and that gives me 2 silvers, right? And it also gives me, how many chlorines? Yep. Very good. Now, is everything all balanced? Is everything equal? Yes. Once everything's equal, now, what are we missing on the top?
The energy coefficient on the right side.
Mm-hmm. And so when you don't need to put any numbers in there, what's going to go in there? A 1. Very good. Okay, so what are my coefficients? 2, 1, 2, and 1. Don't forget the 1 right here, okay? Right? Where do we have a question of on any part here? Does anybody have a question on where we got a number or why we're putting something somewhere? Are we sure? Be positive? Yes, eventually. When? I don't know. It depends on how, probably before we leave for break. Okay? Not after the break, no. Okay, let's go ahead and try a different one. Let's do something like, let's look at something on your worksheet that has a split oxygen. Hold on. Let's do something like, okay, look at number 20. Look at number 20 on your worksheet. You have NH3, you have oxygen, and an NO, that's nitrogen monoxide, and you have water. Yes? Okay. Do I have a polyatomic ion? Actually, yes. But is it on both sides? No. Okay. So we're going to split them up and put all your chemicals. What are the chemicals you have? Nitrogen. Hydrogen. And oxygen. Very good. So how many nitrogen do you have on the reactant side? 1. How many nitrogen do you have on the product side? I have only 1, right? How many hydrogen do I have on the reactant side? Remember the reactant side's to your left. That's 3. And how many hydrogen do I have on my product side? I have 2, right? How many oxygen do I have on my reactant side? 2. And how many oxygen do I have on my product side? I have 1 here and I have 1 here, so that's going to equal to 2, right? Anytime you have a plus in the middle, you're going to always add those 2 separate ones together. Okay? Now, little hint here. whenever you have something that splits, like here, most of the time it's oxygen or hydrogen. Always leave that to the end, okay? So just like when you have a polyatomic ion, you always try to do that first. Whenever something splits, do that last. Because if you do everything else, usually it's going to fit in, okay? All right, it's going to all come together all by itself. All right, so now let's try to go ahead and balance it. What do you want to do first, nitrogen or hydrogen? Actually, hydrogen's what's unequal, right? So what can I put here? Now, I got asked this question last period. Ma'am, if I have an odd number and an even number, 2 can't be divided into 3, so how do I figure that out? Remember, don't be afraid to go to big numbers. You can have coefficients that's a 20 or a 15 or a 30. It's okay. Because at the end, if you have really big numbers, you can always reduce, right? Okay, so always multiply. 3 times 2 is what? 6. So here, 3 times what will give me that 6?
2.
2. So now this 2 gives me 2 nitrogens. And it gives me 6 hydrogen, right? Okay, so now how's that going to change my products? Yep, nitrogen's going to have a 2. And so now that gives me 2 nitrogen. And it's going to change my oxygen, but let's forget that for a moment, right? We're going to leave that to the end. Okay, so now how do I do hydrogen?
3.
Very good. You put it 3, so 3 times 2 gives you that 6. Okay? And that gives me 3 oxygen and 2 oxygen. Is that going to give me some trouble there? Yes, very good. Why? Because it's not an even number, right? Because 2 plus 3 is going to give me what? It's going to give me 5. Can I divide the 2 into 5? Can I divide the 2 into 5? No. So when that happens, you can erase all of your coefficients, erase everything, and double up, and then see how that works, okay? So don't worry about what you had. Erase everything, right? Now, let's go ahead and put a 2 here. So that, no, we had a 2, right? We had a 2. So let's double it and let's make it a 4, yeah. Okay, so that gives me 4 nitrogen. What do I need to do on the product side? A 4, very good. So that gives me 4 nitrogen here. And it changes your oxygen, but let's save that for later. Okay, so now 4 times 3, what's that going to do to hydrogen? That's a 12. Very good. And so 2 times what will give me 12? 6. Very good. And so that gives me 12. All right. So now oxygen's last, right? How many oxygens do I have here? 4. How many oxygens do I have over here? 6. Very good. So now 4 plus the 6, I have a total of 10. Very good. Now can I divide by 2? Yes. So what's going to be my coefficient here? It's going to be a 5. Very good. And that gives me that 10. Is everything equal? Yes. And so what are going to be my coefficients? 4, 5, 4, and 6, right? Now, look at all of them. Can I reduce it? No, I can't. Okay, so it's going to stay that way. That's my actual answer. Okay? Where do we have a question on this one? You see how if it didn't work out, you can erase everything and go back and start with something different at the beginning? Yes? Okay, where do we have a question? Yeah, you can write on the paper. Actually, I'm going to give you a choice. I left some space. This is the only paper where I'm going to leave some space there. So you can either write it on the paper or you can use the whiteboard. Because for some reason, sometimes you guys feel better erasing on the whiteboard than you do on the paper. Okay? So you're going to be able to go back and forth. But I need to see those coefficients in the blank where they're supposed to be. Okay, we got it? Yes? Now, you can work together, but if you have a question, you're going to let me know. Okay, we got it?
How many questions are
Yes? There's 20.
Well, now there's like
Mhm.
15.
all 20 of them?